Hey everyone, welcome to my first take at online lecture. I hope everyone's well and like somewhat excited about learning after being off for 3 weeks. I don't know if that's actually the case or not, but it's probably good to, just sitting at home and being isolated. I hope that this is going to be something that everyone's looking forward to. And hey, regardless, we got to do it. So we are going to be keeping on going with our lectures on anatomy for the foreseeable future. And then if we get more information from the Ministry of Education and from our boards and so on and so on, then I'm sure we're going to be keeping on going with this format for physiology, biomechanics, and the rest of the course. I know that there's so many questions about, what is this online learning going to look like that you probably have at the moment. And I, at the time of this recording at least, which is March 30th, don't have the answers to all of those questions, but I can at least tell you that your midterm report cards are going to be pushed back to a later date or just may not happen. And there is coordination happening with universities. So I hope that this can alleviate some of the stress that you might have about what's going to happen with my midterm mark and how is this going to impact my potential acceptance is to the universities that I've applied to. So everyone's in the same boat. We're going to get through this together, and let's jump into our first lecture on the classification of joints. Oh, by the way, you may be very pleased to hear this, but I have a 15-minute cap on how much time I have on this free app. So, and we're already 2 minutes in, so let's jump into it. All right, so here's your learning goals. You can check those out on your own time. Um, and we are focusing in on joints right now. So we've already talked about this as we've been going through the skeletal system already, but the joints is the meeting place of two or more bones. So these are the points of the body which allows for movement to happen. So we have range of movement taking place at joints. And this range of motion allows for locomotion to occur in conjunction with your muscular system. So we've discussed this already. One of the key functions of the skeletal system is movement, but that movement does not happen if it's not for the muscular system as well. So we will be jumping into the muscular system after the skeletal system, of course, but what muscles do is they are going to originate on one side of a joint and insert on the other side of the joint. And when those muscles contract, they're going to cause the joint to move, and that allows for locomotion to happen. You may be surprised that there are actually more joints than bones in the body, but it kind of makes sense. And if you think about just your carpal bones, right in your hand, the palm of your hand, there are so many different joints that you can have. I mean, your scaphoid's going to be, um, it's going to be articulating with. I have to think about this for a second. Your hamate, um, your tricritrum, and each of those are individual joints for one bone. So each of those carpal bones, depending on where they are in the distal or in the proximal row of the carpal bones, especially if they are in the middle, they might have up to 3 or 4 different articulations. One bone, 3 or 4 different joints. Uh, Thus allowing us to have more joints than there are bones in the body. I think I got to speed up already. All right, so we have 2 different ways that we can classify joints. The first way is functional. So this is what do the joints do? And we're going to classify these by movement. The next is structural, and this is what the joints are made out of. So the key structures of the joints are going to differentiate themselves based on being fibrous or synovial joints or cartilaginous joints. And we'll get to what those mean just coming right up. So for the functional classifications, we have synarthrosis joints, which don't allow for any movement. Then we have ampliarthrosis joints, which allow for some movement, and diarthrosis joints allow for maximum movement. So synarthrosis joints, these are one of the characteristics of them is that they're immovable or nearly immovable, and I'll explain what that means. But classic examples of these would be the sutures of the skull. So when we think about the skull, we think of one bone, but these are actually a number of different bones, as we've learned, that are connected together through fibrous joints. So there's really dense fibrous connective tissue that connects these bones together, and they allow for no movement. However, osteopathy does allow for some very slight movement between the different bones, and that's why we say that they're nearly immovable. Other examples of this would be your teeth. So you can see on the cursor just over here, your teeth not allowing for very much movement. With high impact, of course, they could fall, like the teeth could fall out. So however, they're pretty stuck in there for a lifetime. They may not move. Also, we have the interosseous membrane between the tibia and fibula, as well as between your radius and ulna, and those joints are not allowing for very much movement. Other example would be between your sternum and manubrium. We've learned about this. There's when we talked about the sternum in the skeletal portion, but this joint right here between the manubrium and the sternal body, or the body of the sternum, doesn't allow for any movement, and we often think about these two separate bones as one bone since there is no movement. Then we have ampliarthrosis joints. These allow for partial movement. So a great example of this would be the joints of your spine. So between each vertebrae, there's slight movement that will occur, typically rotational movement, but there can be flexion extension in the sagittal plane, as well as lateral flexion in the frontal plane as well. So some movement can occur there. We don't want there to be too much movement because our spine, it's a stability structure. We want there to be limited amount of movement so that our internal organs are going to be more protected, and all of the various protective features and structural features that the spine gives us. But some movement is very important because it's going to help with shock absorption. It's going to help with just increased range of motion. If we can't laterally rotate, for example, we're not going to, our hands, which are highly mobile, and our limbs, which have a tremendous amount of mobility, aren't going to be as useful without some movement occurring at the vertebral column as well. Other examples would be the pubis joint. So that's the pubis symphysis we talked about during being integral during birthing. Then your ribs, where they meet the sternum anteriorly and the vertebrae posteriorly, those are going to allow for some movement so that your ribs don't break so often if you incidentally knock your thoracic cage, also known as your rib cage, against something. So you can see here the two articulating surfaces of this thoracic vertebrae is going to allow for some movement, and that's why it's classified as ampliarthrosis, which is its functional classification. The last functional classification is diarthrosis. So this allows for maximum movement. So fully movable, these are the joints that are typically related to locomotion. So your limbs are all made up of diarthrosis joints. There are always synovial joints, which is a structural classification, which we're going to be talking about next. And there's a fibrous joint capsule that surrounds these joints and allows for increased movement and lubrication. And we're going to talk a little bit more about that. So examples would be your knee, your elbow, your shoulders, your fingers. Any joint that moves quite a bit would be diarthrosis. So moving on to structural classifications, you can see that we have fibrous, we have cartilaginous, and then we have synovial. So once again, these are structural. We classify them based on the types of material that are present and consistent in each of these categories. So fibrous, cartilaginous, and then lastly synovial, meaning it has a synovial capsule. So fibrous joints, we're looking here at the radius ulna and the interosseous membrane that goes between them. So that is some dense fibrous connective tissue that connects the radius and ulna and allows for pronation and supination to occur without too much movement taking place between the radius and ulna. Also, we talk about the sutures of the skull and your teeth. So it pretty much overlaps exactly with the synarthrosis functional classification. Then we have our cartilaginous joints. It's very much overlaps with the amphioarthrosis functional classification, but here, since we're classifying it by joint structure, this is cartilaginous, so there is some cartilage that's in these joints that allows for some movement. So shock absorption allows for some movement. Intervertebral discs, pubis symphysis, allowing for some movement. Synovial joints. So these are joints that allow for, or based on the structure, have a capsule encompassing the entire joint structure. So the two articulation surfaces of the connecting bones. And synovial capsule is made up of fibrous connective tissue that is continuous, so it fully encapsulates the joint, allows for full movement almost exclusively in the appendicular skeleton. So once again, that's the part of our body that's primarily responsible for locomotion. And then synovial fluid is going to fill this joint capsule to help lubricate the joints, reduce friction on the articulating surfaces, which is going to reduce injury and increase the lifespan of that joint. It also helps produce some nutrients are produced inside that synovial joint capsule. It is going to reduce the amount of heat that is produced from friction. It's also going to absorb some shock as well. So examples of these would be your knee, your elbow, your shoulder, your fingers, your ankle, your hip, your toes. Yeah, I mean, those are pretty much the main ones. Your entire appendicular skeleton. So articular cartilage surrounding the diaphyses, my apologies, the epiphyses of each of the bones. Ligaments are dense connective tissue that connect bone to bone. We've talked about this in class a couple times. Ligaments connect bone to bone. Tendons connect bone to muscle, and then we have fascia, which connects muscle to muscle. So there can be some intrinsic ligaments which are inside the joint cavity, and the extrinsic. The joint cavity is all inside this joint capsule. Synovial fluid. This is very viscous fluid which reduces friction. So think about almost like molasses type substance inside the joint capsule. The joint capsule is continuous with the periosteum of the bones. Remember that's that kind of fibrous wrapping around bones. So if this were I don't know, it's probably an elbow joint. Let's say the periosteum is this blue portion coming off the humerus. It's going to be continuous here and go down onto the radius or ulna, whatever this bone represents over here. And then there's also going to be sensory nerve fibers and blood vessels, which are going to help bring nutrients into the joint capsule. And then also there's bursa, which are small fluid-like sacs. And you can see the bursa here, which are going to help with some shock absorption and also articulation. This is the part that gets interesting. Got to be very quick, so I think I have 15 seconds left. But pivot joints, your neck, ball and socket joints, your hip and your shoulders. Condyloid joints would be your ankles and wrists. Plane joints, your carpal bones, tarsal bones, and saddle joints